23rd June 2025, 11 years of achievements of the Ministry of Science and Technology and Ministry of Earth Sciences were showcased at the National Media Centre, New Delhi, in the gracious presence of Dr. Jitendra Singh, Honorable Minister of Science and Technology, Independent Charge, and Minister of Earth Sciences. In this conference, secretaries of different departments and ministries presented the 11 years achievements. Dr. Abhay, Karandikar, Secretary, Department of Science and Technology, presented a comprehensive review of the scientific advancements made in the last decade, applauding the synergy between research institutions and startups that has turned ideation into economic success stories.
The Department of Science and Technology is one of the nodal ministries for the extramural funding across academic institutions. So it has spearheaded research and innovation in the country, build R&D infrastructure, and also strengthen the India's global leadership. In last 11 years, we have spearheaded 5 key national missions, have transformed the scientific infrastructure landscape, the development of this infrastructure across academic institutions, universities, and research labs, nurtured scientific talent and developed human capacity right from school level innovation to supporting women in science, enabled the innovation and deep tech innovation ecosystem and entrepreneurship through our incubators and startup support schemes, and elevated the India's position in global science through strategic collaborations and participation in several mega science. In terms of human capacity building, we led a flagship program which is Innovation in Science Pursuit for Inspired Research, that is INSPIRE program, which has several components at school level, Manak, undergraduate scholarship, PhD fellowships and faculty fellowships. And in the last 11 years, we have supported close to 8,000 PhD fellowships, more than 1 lakh undergraduate fellowships, about 1,282 faculty fellowships, more than 7 lakh school level, innovation students. The Department of Science and Technology also runs a very flagship Women in Science program. There are several components of this. The details are there in the booklet, that has been provided to all of you. But to summarize, we have supported 5,000 women scientists, either through the postdoctoral or, doctoral research programs. Also at the school level, through the Vigyan Jyoti program, 82,000 plus girls have been supported to study STEM education. And through our Curie program, we have supported several women-specific institutions. As I mentioned, in the last 11 years, we had several key missions. One, of course, jointly with Ministry of Electronics and Information Technology, we were part of National Supercomputing Mission, which has established the India's supercomputing network. Then, the National Mission on Cyber Physical System. We have set up 25 mission hubs across the country, and now in the last 1 year, we have upgraded 4 of them to the Technology Translational Research Parks. We have also set up 4 mission hubs: quantum computing, quantum communication, quantum sensing, and quantum materials and devices. And as a part of our national quantum mission, we have also supported 8 startups which have been working in various areas of quantum technology. The National Quantum Mission supports 14 technical groups and more than 150 researchers across more than 40 institutions in the country. We are a part of National Action Plan on Climate Change, and under which we led 2 national missions, one on sustaining the Himalayan ecosystem and other one on strategic knowledge for climate change. And in both these missions, we have contributed to building knowledge support, funding climate research, and generating knowledge networks and information systems. As all of you know that in 2021, the Government of India liberalized the geospatial sector through the geospatial guidelines, and the National Geospatial Policy, which was approved by the Cabinet in 2022, set the vision for using mapping and location data in governance and development. So this was key reforms which was undertaken in the geospatial sector, not only in terms of liberalizing the geospatial sectors, but also reforming the Survey of India. The National Geospatial Mission subsequently was announced in this budget. We are now in the process of getting the Cabinet approvals for that to implement many of the objectives of the National Geospatial Policy. In terms of technology translation and innovation ecosystem, Department of Science and Technology was one of the important ministry for nurturing the startup ecosystem in the country. When the Honorable Prime Minister gave a clarion call of Startup India in 2016, the DST launched the Nidhi program, that is National Initiative for Developing and Harnessing Innovations. And through this program, we have supported 9 centers of excellence, 39 technology business incubators, and 48 inclusive technology business incubators. And through these incubators, we have supported more than 5,000 startups, which has led to 30,000 plus job creations. And as you know that almost all of these startups are technology areas. There are several components of the Nidhi, the entrepreneurship in residence, the seed support program, the Prayas and all of them have been hugely popular among the first generation entrepreneurs. The Department of Science and Technology has taken several important initiatives in the past decades to set up world-class R&D infrastructure across India in both premier academic institutions as well as universities. For example, in terms of through FIST program, we have supported 400 institutions, 1,100 departments in terms of facility creations. In PERS program, we have supported 91 universities for their R&D infrastructures. We also launched a very flagship program 3 years back of Sathi, which is created a national level facility. In terms of international science collaborations, we have several bilateral and multilateral collaborations, and I will not go in details of this, but I would just like to point out some of the mega science projects of which India is a consortium partner, and Department of Science and Technology has enabled this. For example, 30-meter telescope, square kilometer array, FAIR, CERN, LIGO, and now a national solar telescope will also come up. In science heritage and initiatives, we have been supporting bridging traditions with technology, and under these programs, we have supported several thematic centers. We have funded indigenous technology for protection of heritage structures and also for reviving heritage through science and innovation. Finally, as you know that the establishment of Anusandhan National Research Foundation was a very transformative step in the entire R&D ecosystem. NRF itself has launched several R&D programs, and the details are there in the booklet which has been provided to you. But this year budget also made a major announcement of setting up a research development and innovation fund for boosting the private sector R&D, and this fund is going to invest in this year in the private sectors. The fund will be housed within ANRF as an independent business unit. It will primarily encourage the private sector to scale up research and development in the sunrise domains. So thank you very much. These were briefly achievements of the Department of Science and Technology. Would just like to mention that we have not only supported research development and innovations, R&D infrastructures, and have also supported the startup and innovation ecosystems.
Dr. Rajesh Gokhale, Secretary DBT, referred to the development of 7 vaccines, the filing of over 1,750 patents, the sequencing of more than 3 lakh COVID genomes, and the rise of the biotech economy to $165.7 billion.
I think largely we've contributed, and this is how the ecosystem has grown. It's become so vibrant and so active now in the country that it tells you something about what it has done. So for example, more than 25,000 publications have come out of this in last 11 years, about 1,750 patents, and this is about DBT only actually. Of course, DST, Earth Sciences and CSIR and other institutions must have contributed a little bit more as well actually. More than 62,000 of human resource trained in this time, about 1,800 products and technologies being emerged out of it. About 5,530 projects have been sanctioned. The bioeconomy now, which is BIRAC's prerogative, is actually of $165.7 billion industry now. There's more than 10,000 biotech startups supported. More than about 95 bioincubators are present in the country. 800 biotech products in the market actually, which you can buy on online product, and about more than 7,000 crore of private fund raised by various startups ecosystem, giving you an opportunity of how it has worked. It's about 7 vaccines have been developed, which is unprecedented for the country actually in last 11 years. Never before country has seen such mammoth changes. 3 speed breeding platforms has been established. These are platforms that allows you to do day-night cycle changes in a shorter period of time so that you can manage life cycle plants. More than 10,000 Indian human genomes mapped, 56 improved food crop varieties released, and about more than 3 lakh COVID-19 genome sequences have done. So it gives you a little bit of an overview of what we have been able to achieve over the period of time in a spectacular fashion, actually government-supported ways.
Dr. N. Kaleiselvi, Secretary DSIR and DG CSIR, shared innovations across CSIR's 37 labs that are driving industry-grade impact across India.
DSIR as a department, CSIR as an autonomous organization, CEL as a PSU, NRDC as another PSU. The arrangement is like this. CSIR is not a funding organization. CSIR is a performing and implementing on. Therefore, CSIR comes up with a kind of a technology development. Motto is we have to serve to Indian industries through indigenous technologies. Therefore, technologies are getting developed from CSIR, and the technologies are reaching MSMEs and startups through different channels. NRDC is one channel, and whenever the technologies we are reaching a particular TRL value, CEL is there to scale it up to a higher level, and DSIR is there to recognize the industries who can really take it up, and they are taking care of the registration of industries also who can really play and do justice in the field of R&D. So with this kind of a background, DSIR, I have taken only one example, CRTDH. Through this scheme alone, number of beneficiaries, I would say in the name of MSMEs, 2,582. On the whole, I can say around 10,000 beneficiaries, they have thoroughly enjoyed DSIR's handholding. And in the case of NRDC, again, 11,000 startups, they have really helped. Within our own organization, NRDC is taking care of the startups, and DSIR is taking care of the MSMEs, and CSIR is taking care of the technology development. This is our portfolio. So NRDC, now they are coming up with a kind of a one-stop shop for startups, and they are coming up with the national technology assessment-related design clinics as well as certification also. We call it as Netra. Once CEL was considered under disinvestment, now it has grown up to the level that it has acquired the status of Mini Ratna. During this particular period itself, their PBT is around 100 crore, and profit for the last year alone is 74 crore, and the dividend payout in the last 1 year is 22 crore. CSIR, it's a big family again. 10,000 scientists are there, family members are there. For the year 2014, CSIR helped this country to come up with the wax de-oiling technology, by means of which Numaligarh refinery, they are now practicing this technology at the commercial scale. And in the year 2015, CSIR came up with the indigenous technology for hydrogen hydrate. Today, in the Dahej complex, 10,000 ton per annum production of hydrogen hydrate is taking place. And the third one is in the year 2016, it is again a game changer. CLRA came up with a kind of a waterless chrome tanning technology, and it is very popular. And in 17, it is IIP's technology. It is first biofuel-powered flight. Actually, SpiceJet has used, even our Republic Parade time also, fly-past aircrafts. Last year also, 2 of the Dornier aircrafts, they used only CSIR IIP's sustainable aviation fuel only. And in the year 2018, we have come up with a kind of a purple revolution. So the Jammu and Kashmir, and now it is spreading to other parts of the country also. More than 3,000 agri startups are really getting benefit out of this purple revolution through the lavender cultivation. And in the year 2019, it is the AGR technology. So in Hyderabad, in the vegetable market, Bovanpalli market, so it is the 10 ton per day, it is able to produce the cooking gas from the vegetable market waste. And in the year 2021, we came up with a kind of the first maiden flight of Hansa new generation NG aircraft. And India's first hydrogen fuel cell bus also, we were able to demonstrate at that point of time. 21-22, again, we had number of success stories with respect to our steel slag road technology. And in the history of India, this is the first time India got the Steel Slag Award for the first time in the international arena because of this particular technology. 22-23, again, we introduced the e-tractor, Prima. It is a women-friendly e-tractor. So we have been developing, and this is the first time we have launched the e-tractor. And the year 23-24, we have come up with a kind of a rapid testing kit for sickle cell anemia. The country was really recalling the importance of eradication of sickle cell anemia. So we are now coming up with a kind of a fast analyzing kit. It is a molecular diagnosis kit. So the kit is going to cost less than 100 rupees. It is going to be available in market from this year onwards. And in the case of 24-25, we are so proud, we got the trademark for 2 of our technologies in the name of CSIR. One is steel slag road technology, the other one is Indian Standard Time. 2 days back, you would have even read in the newspaper, One Nation, One Time. NPL, they are coming up with a kind of a success story with respect to the atomic clock. So if at all, even the GPS, that particular facility is denied also, India need not worry about it in future because we are coming up with our own indigenized time management also.
Dr. Ravichandran, Secretary, Ministry of Earth Sciences, shared that forecast accuracy, radar deployment and real-time disaster early warnings have significantly improved, especially across the Delhi NCR region.
I want to say that Ministry of Earth Science mandate is to translate, do science and translate science to the services for the benefit of society. The first objective is to provide services, and the second objective is to explore and develop technology for harnessing living and non-living resources, especially the ocean. And the third objective is explore the polar regions, especially cryospheric component. So in that aspect, in the first one is basically in the atmospheric section, what we have done in improvements in weather and climate. This bar diagram shows that basically we started from milliseconds or few seconds lightning, which is a forecast. Earlier it was not available. Now, because thanks to government, it has installed more than 100 lightning location system. Because of that, now we are able to provide the lightning location services. Number two, the cyclone. Also, we are able to improve the forecast more than 30%, not only intensity, but also in the track and the landfall. Huge savings because of the life property and maybe the property saving, as well as the not required to mobilize major mitigation measures. And the third aspect is short-term forecast. It is up to few days, and the few days forecast also we have improved significantly because of the various models and observing systems. And the fourth one is the extended range forecast, which was not available earlier because it is only for the next month how it will be. That give the weekly information. Earlier it was not there. Now we are able to provide the extended week, because this is very important for the agriculture, what crop they have to show and other purpose. It is newly introduced in the recent decade. And the seasonal prediction, basically earlier we were dealing only from the statistical model, how much rainfall will happen all over India. But now we are using the dynamical physics-based model. With that, we are able to say each spatial, how it will be vary, and how much we are able to make it. With this, we are able to improve the accuracy of the forecast. Also, we are able to give the spatial granular information. And the last one is basically the decadal forecast. Only 4 countries in the world are able to provide the decadal forecast. India is one among them. That is, we are able to start the decadal forecast. That means next decade, how it will be, how the monsoon will be, how the weather pattern will be. All this information we are able to provide from the decadal forecast. Climate, it is about next to 2100 years how it will be. So we are also providing, India first time we have joined in IPCC report. So our models is one of the IPCC finalization report. These are the various temporal scale we are able to improve major things. And the last one basically not only for the temporal resolution, spatial resolution also we are able to improve. The weather, and not only for the weather forecast, but also we have improved the air quality monitoring, and also we have made weather modification. From the weather modification, how much we can enhance the precipitation. Roughly, we have documented about 18% only we can enhance the artificial cloud making and other things. And also we are able to improve the HPC and observations. Because of improvement, because of more funding, because of more number of observations, because of HPC, we are able to improve various forecast systems. And also we are able to make a thunderstorm. We are able to quantitative precipitation forecast also we have improved very significantly. Coming back to the ocean, of course, we are able to improve. We are trying to go towards the blue economy component of the ocean sector. For that, we are able to map how much energy is available from the ocean. We are able to map it. In India, almost roughly about 9.2 lakh terawatt of power is available per annum. And potential fishing zone. Earlier, we used to give the mass, where the fish mass is available. Now we are able to provide the species-specific forecast for the various states. Thereby, our user, it has been almost 7 times have increased. And also we are able to give the forecast of the ocean parameters, various parameters, wave, wind, currents, and to the various stakeholders, including shipping, port and harbor and other people. And also we are continuously monitoring seawater quality among the all around the ocean, and we are able to monitor various things. And important thing is one of the significant thing is a tsunami early warning system, which has been one of the unique best tsunami warning system in the world that has been recognized by IOC. So that is also we have established in the recent years. Apart from that, we are able to make the digital ocean, and this digital ocean is various observation in situ or radars or satellite or model. All this observation we put into the digital ocean, wherein any depth you go, any time you go, you will be able to see various parameters that we have made it a digital ocean. And also we have made recently the SNOPS, that is basically the operating system. We have established one of the state-of-the-art operational system. Global ocean we are able to access at any point from Hyderabad. And also we are able to make biodiversity surveys under the Deep Ocean Mission. And also we have strengthened the coastal resilience through various measures, marine spatial planning, like urban planning, we are able to make marine spatial planning, and also shoreline, how it is changes over the period. All these things we are able to document it. And also we develop various technology, either it is Samudrayan or the ocean observation system, water desalination of water or mining machine, or to make what is called a natural-based solution for beach creations or any other coastal ecosystem. And also exploring poles, we are able to make various teleconnections. We are able to relate the polar connections with the tropical regions. Majorly what we have done is we have made an Arctic policy and also Antarctic bill. It was waiting for long years, long decades. Now we are able to make a polar bill, that is especially Antarctic bill. And also we are able to make Arctic is India's scenario we are able to create in the Arctic. And in the coming to the solid earth, in the seismic network, we have increased from 84 to 168. Thereby, we are able to monitor any earthquake or more than 3. Within 3 minutes, we are able to monitor. And also, we have done major microjonation of major cities where we have to build and what we should not build in that aspect. And also, we have made a drip drilling. It is about just whether we want to know whether we can get any precursor for earthquake. For that, we have made a 3-kilometer deep drill, and in that we have instrumented various monitoring mechanisms we have installed. We are trying to understand is there any precursor is available or not. Also there are about many geological things. It is a curiosity driven questions we are able to answer from various aspects, and new program we have started. It is submarine groundwater discharge and various other aspects. And I think we are part of life of every individual as well as every ministry. That is what we have created in the last 10 years or so. It is all because of again I am telling it is because of the funding and observation and understanding. I think from 2014 we have a funding of 1,600 crore. Now we are having 3,650 crore per year. And for this we want to observe more, understand more, and predict models we develop so that we can produce various services. So our objective is do science and translate science to the service for the benefit of society.
Principal Scientific Advisor, PSA, Government of India, Professor Ajay Kumar Sood said,
This Office of Principal Scientific Advisor provides evidence-based practical advice on key issues related to science and technology. Actually, it plays a role in assessing the current landscape of various scientific domains, all the ministries, cutting across ministries. We are ministry agnostic, identifying challenges, formulating interventions that contribute to future-ready roadmap for national development. In this, the Prime Minister's Science, Technology and Innovation Advisory Council, PM STI, serves as an important platform in this process, which provides an integrated framework, strategy, design, and implementation. So the way it works is that it identifies critical gaps that hinder optimal national performance and assess the evolving global R&D landscape, determine priority areas essential for India's growth and leadership. Now, based on this analysis, PM STI in the last 11 years targeted missions, actually to be more specific, 11 of them, initiated policies and other interventions. Now, these are then operationalized by respective ministries or departments and to ensure coordinated and mission-driven action across the national innovation. So that is the framework of from the science policy to the action by involving all the relevant stakeholders in this ecosystem. So as you would have noticed in the last few years, many missions have been launched. For example, National One Health Mission, which cuts across 13 ministries. You heard about National Quantum Mission, National AI Mission, Deep Ocean Mission, Bio E3 policy, and many things which have happened in like Green Hydrogen Mission and so on. So this is the role our office can play in energizing science and technology ecosystem. ANRF, which was also mentioned, again was discussed very extensively in PM STI quite early, and from there it has come to the fructification and rolling out last year of this very important initiative of this government. Just to tell you some brief, if you don't have, last year at the completion of 10 years, our office in conjunction with 22 departments had looked at science and technology panorama for Atmanirbhar Bharat. It is on our website. This is a very, very short summary, which is theme-wise, what all ministries have done in various themes. And if you have interest, you can look at, which is really like the area-oriented summary all government as a whole have done. We also unveiled ONOS, One Nation, One Subscription, which again I feel is a very, very important outcome under this government's initiative, which makes access, democratized the access to almost 1.8 crore student faculty members, and they have access to almost 13,400 international journals, cutting across in 6,300 institutions. This has never happened before, and this will really be a game changer in really taking S&T to the grassroots level in the true sense of the word. So we have iSTEM, which again is a program where equipments and the facilities acquired under Science Ministry's funding, like what you see on the dais, they are on the portal and they are accessible to everyone. And this also is making a difference. The RUTAG, which is really taking science and technology to the villagers, RUTAG Smart Village Centers, again seeing how the technology really goes to the grassroots level. All these are ones where our office plays a role along with all the science departments and other departments. 11 years of achievements across our premier science and technology departments, institutions. We recognize fully well that the foundation for the next decade of growth and innovation is well underway. And for this, we all thank the leadership of our Honorable Prime Minister. He has made very, very clear in all his addresses from the Red Fort and all other occasions in G20 and so on, how science and technology is at the center stage for India's growth. And I am very sure that through various ministries, departments, institutions, strategic sectors, all these will continue to remain committed to advance science and technology for inclusive development, sustainability, and global cooperation.
Honorable Minister of State Independent Charge for Science and Technology and Earth Sciences, Dr. Jitendra Singh remarked.
The last 11 years turned technology as the engine of India growth story. And that's there for anyone to see with evidence. Also, the last 10 years turned India into a technology leader rather than a technology follower. And thirdly, the last 10 years coming out with global best practices for others to follow, instead of waiting to adopt the best practices developed by others. So I think these three sentences sum up about all. And this has been possible largely because after 2014 we had a political dispensation which was very supportive. And I think what the scientist needs the most is the liberty to experiment, even sometimes at the risk of not being as successful as envisaged. And that was allowed to us by the Honorable Prime Minister, whether it was in the case of going out for private participation, even in departments like space and nuclear sector, or going out of way to involve even foreign collaborations and FDIs. Because we never lacked talent, we never lacked the potential, but perhaps what was lacking was A, a political dispensation, and a supportive approach which happens from the level of the policymakers, and B, that we had refrained ourselves from following the global strategies which drove us into working in silos, unlike what is seen or witnessed in the other countries where there's no demarcation between the private and the public sector. Now, this has also given huge importance to all these science departments that you see over here. And as I was saying, it's also generated interest in the media and the people outside these departments. When I came here and when Ravichandran joined, I asked him, I sometimes feel like doing a survey on the streets of Delhi, give them a performer and ask them where on earth is the Department of Earth Sciences. Today I'm glad people come looking and ask where is Prithvi Bhavan. So that is the kind. Now similarly, the Department of Biotechnology had been dumped behind ITBP. So when you went looking for him, you came across all the uniformed cops. your first reaction would be that you landed at a wrong place. Today, young boys and girls are demanding that we need to have a proper address because we want to avail of BIRAC, we want to avail of the startups. We have just 50 startups in 2014. Now they are more than 10,000, 11,000. So that is the visibility. Similarly, Department of Science and Technology has its own technology bhavan now, a huge complex befitting of the kind of work that they are doing at Mehroli. They are no longer confined to a small section. And of course, CSIR, I need not say, we introduced a program called 1 Week, 1 Lab. She presides over 37 labs and the PSU, but hardly anything was known about it. In fact, when we started involving public engagement with each of the labs, and I would say let the people talk about us, what they think. And one of the places where we had a farmers' interaction, because the institute was dedicated more to the agri schemes, they came out with some hilarious observations. Some of them said, we used to pass by this gate, we didn't know what is happening. If we asked the passerby, he said, don't ask, andar mendak kaate jate hain, lab hai. Somebody said the ghosts dance in the night. So we have opened up, all the 37 labs opened up. So this visibility is not only to showcase ourselves or to give us some kind of a satisfaction out of publicity, whatever has happened, but also that we have reached out to the stakeholders. So that is something which was not mentioned in any of the earlier presentations. Today we are very much linked with those for whom these gentlemen and gentleladies work, and those who have to avail of us. So we are much closer now through these interactive programs. Now we have also launched one theme 1 week, so that all the institutes working on a similar theme come together in an integrated fashion. And that is the global strategy which is followed by the successful nation. The other hallmark has been that most of these departments have tried to explore areas which were hitherto unexplored. Today, reached from 10th to 4th economy. But as members of the scientific fraternity, we are not expected simply to romantically and fancifully keep saying we'll be number one, we'll be number one. That might suit others. We are expected to come out with scientific evidence about what is the roadmap. And if you scientifically try to ponder over it, the roadmap is to explore those areas which have not been explored earlier or have remained underexplored, or the sectors, the regions. That only will add value to bring us from 4 to 3 and subsequently to 2 and 1. And I'm glad, and that's, I think, I know how far we have noticed. Department of Biotechnology, and look at, have you ever realized what were the greatest assets, natural assets of India, resource pool, which unfortunately remained underexplored for the last 70 years? One is biodiversity. We keep saying unity in diversity, unity in diversity, unity in diversity, without even understanding what it is all about. But have we ever made a virtue out of this diversity? This diversity itself is our exclusive resource, not given to any other country in the world, where you have very homogeneous composition, both resource-wise and otherwise. And for the first time, I'm glad this biodiversity Department of Biotechnology, headed by Dr. Rajesh Gokhale, and as was being mentioned, this is going to be the foundation of the next industrial revolution. We are already into it, as he was mentioning, with institutionalized policies like BioE3. So we have already started moving in that direction. And this resource is going to add value to our future economic growth. The second area which remained underexplored for 7 decades was our ocean resource. We have 11,000 kilometer long coastal area. We have almost 12 states residing on the banks of the oceans. We have an ocean called Indian Ocean by the name of the country, which no other has. But we never looked into it. We never peeped into it. The first time, huge resource of minerals, metals, fisheries. When the metals, minerals and fisheries on the surface of Earth get exhausted, saturated, where are you going to add value to? How do you reach from 4 to 1? This is, so department has started exploring that. And third, natural resource only given to India. Like I said, biodiversity 1, oceans 2, and the third, again, not exactly realized for almost 7 days, the Himalayas. And I'm glad the department has started looking into Himalayas. This purple revolution emanating from Himalayas is becoming a new genre of agri-startups, a new genre of livelihood, and a very lucrative livelihood, also exploding the Western myth that to be a startup, you have to be an IT man. To be a startup, you have to be a PhD. Many of our startups are not even graduates. And that is indigenous startup emanating from the lap of Himalaya. So these 3 major sectors which had remained underexplored or unexplored for the last 7 decades are now getting explored by these 3 departments. And this is exactly going to add value when we reach economy number 1. Then in the process, as I said, this has also led to the discovery of the talent which had hitherto remained undiscovered. Because we had so many myths. The startup has to be an IT, startup has to be very great scientists. They can't, I think, even write the spelling of science, yes, but they have an aptitude for technology. They have an aptitude for passion for the technology, and they are very good learners. The other notable feature of these last few years has been that we have worked in the true spirit of cooperative federalism, which the policymakers keep saying, and science departments are not expected to be a part of it. We are indeed. Our science council is much more active now. There were times in these states, no civil servant would like to be a science secretary, because he would always keep waiting to be transferred to another department, and therefore the departments would remain neglected. Now realizing, now we have aligned those technologies with public welfare programs, which has given esteem, whether it's a Swamitva program, whether it's a Jal Jeevan mission, whether it's your soil health agriculture schemes. All these schemes, because of their close alignment with technology, the science departments in these states have also started collaborating. And lastly, I'll just give one each global best practice emanating from each of the departments and being emulated by the rest of the world. As I said, we have learned to speak with evidence, so this can also be verified by anyone. The best practice from the Department of Biotechnology, vaccine, the first ever DNA vaccine, now being emulated by the other countries. They are in fact wondering, a country hardly known for healthcare practices has come out to become leader in the preventive healthcare. And B, a global best practice of successful gene trial in hemophilia, which is again a global problem. In fact, hemophilia was also once upon a time known as Queen's disease. The earlier books, if you find 19th century textbooks written by the British authors, because then after 1980 or so, the entire medicine and science academics shifted over from Britain to America. So the earlier authors used to call it Queen's disease because one of the Queen Victoria's relatives had this. It emanated from there. It was worked upon there. Deficiency of clotting factor 8, leading on to bleeding. Uncontrolled, many people would succumb to a bleeding if they had an accident or a trauma. The first gene trial successful has not happened where it was first reported. It has happened through the Department of Biotechnology with a trial conducted at Christian Medical College, Vellore, and it has been reported by none less than New England Journal of Medicine, which is among the oldest science journals, almost 200 years old. New England Journal of Medicine and the British Medical Journal, the two oldest journals emanating from the Great Britain. So that is the other global best practice. Now, for the Department of Science and Technology, the geospatial policy, lesser talked about, but it's emerged as a global practice. The Swamitva program is also greatly guided by this policy. And the world is wondering how a country as heterogeneous, as vast as India, it's also a peninsula, it's also a Himalaya, it has also island territories, it has also got hill terrains. You could come out with a practice of mapping using drones and satellite images, and you have put the revenue officer out of job. You have made the farmer, the landowner, the master of his own destiny. And that is exactly the spirit of citizen-centric governance. As I said, we have aligned our technologies with the governance. So there is again a global practice which is to be followed. As far as the Ministry of Earth Sciences is concerned, way back in 2016 or 17, we came out with a satellite. Earlier, the idea was to name it SAR satellite, and of course it was not named because Pakistan refused to be a part of it, and of course that's their misfortune. But that satellite is now offering services, both the disaster predictions, disaster evaluation information, to all the countries around. Neighbors First policy launched by Prime Minister Modi through the MES is being supplemented by the Ministry of Earth Sciences. Whether it's Mongolia, it's Bangladesh, Nepal, Sri Lanka, the information being catered by this department through IMD has actually enhanced India's reach and emerged as a global practice. And similarly also, forays into Antarctica are now also of a much superior quality compared to many other countries. In fact, we even went to the extent of performing yoga over there among penguins and the ice. And I need not mention the CSIR global best practice, purple evolution and lavender.
In the change scenario over the last 1 decade, India is not just participating but is shaping global scientific discourse, setting benchmarks for others to follow. India has moved from the sidelines to the center stage of the global scientific ecosystem due to pioneering reforms, citizen-centric innovations, and out-of-the-box decisions. The multiplier impact of these reforms is being seen across sectors: agriculture, education, disaster management, defense, governance, and even climate resilience. Narrated by Kaushik Roy and produced by Dilip Jha, this broadcast came to you from the Indraprasth channel of Akashvani, Delhi.